In the previous video, we loaded their data into tensors. Now we're going to look at what happens when they click on train model from scratch. So when they click this button, we're going to go into this function here, and then we get our tensors passed in with the data. So xtrain, if we remember, was our training data, and then we've got test data as well. So we have some parameters here. We have 40 complete training cycles with the data, and we have this learning rate, which we'll be using for gradient descent. So let's just jump over this. You can see here, it's updated the UI here, and then we load the parameters in, and then we're going to start a new model. So TensorFlow sequential is part of the layers API. If you looked at our previous one of our previous videos on polynomial regression, we didn't use the layers API. We used a low-level TensorFlow.js library. But here, what we're going to do is this is the layers API, and it's a lot easier to use for making neural networks. In Python, this is called the Keras model, but for simplicity, they've just called layers in TensorFlow.js. So this is basically what we do. We add two layers. We add a dense layer. A dense layer means that every neuron is connected to every other neuron in the input. And then we have another dense layer after that. So this is beyond the scope of this video, but there's activation functions for neurons, and they determine when values will be passed and when will not be passed. And these are mathematical functions that you can go on Google about and see what they do. But what they basically do is they add non-linearity to the model, which allows you to produce, I guess, more complicated models. If these activation functions were linear, then we wouldn't be able to train and find results in a machine learning network. And then we add an optimizer. So an optimizer is what they use to optimize the model so that you get the correct results. This ADAM is probably one of the latest forms of gradient descent. It's something to do with adaptive momentum. Again, what exactly ADAM does and why it's good is beyond the scope of this video, but pretty much it's, of all the gradient descent methods out there, this is probably the most powerful, and I guess you could use it for more generic examples. It isn't just specifically for the Iris demo, although it's a pretty simple demo dataset. Just ADAM is used quite a lot. And so basically the ADAM finds the right values for the model. And then we have this model compile statement, which is used for all these layer demos. And they have this loss function called categorical cross entropy. What it will tell you is if we have, say, an expected distribution of probabilities, and then we have a distribution of probabilities for our training set, and they don't match, this categorical cross entropy will give us the degree that they don't match. And so the optimizer works in conjunction with the loss function here to find the best values for the model. That is basically what it does. And then this metrics accuracy will basically use those to show on a chart how we're doing. So TensorFlow.js has a callback for a model called onEpochEnds, and because we're using these accuracy metrics, every time we finish a complete training set, we will get the values of how good our loss values are, and then we can actually plot them onto the UI. So let's just step over this. So we just setting up the model to train. There is a lot of magic going on here with the layers API. If you looked at the previous video that we had, there was a lot of setting this up ourselves. But the beauty of this is, even though it's a bit magical, it does wrap around a lot of the complexity. So we just create some arrays here, and we're going to use this to store the values of the on the checkpoints here, or on the epoch end. Basically, on epoch means when we finish a cycle through this training data. So let's just continue this. So I'm just going to press F8 to run through the code. Okay, where are we? Okay, so we've finished an epoch. So let's just inspect what this is. So epoch 1, we've been one cycle through it, and we have some logs. So this is saying that we have an accuracy of 0.3 and a loss of 1.3. I'm not sure what val ax and val loss is. If anyone knows what that is, please write in the comments below. And then we just got a UI function, which I won't bother going into, but what it does is it starts to plot these values. So let's just press F8 to get to the next epoch. So there we are. There's our values plotted there. So the next one, we're at epoch 2, and we can see that our accuracy has gone up and our loss has gone down. So I'm just going to put a breakpoint here now, and I'm going to continue this. So there we go. We can see our losses are going down, down, down here, and after we get to 40 epochs, then we'll be satisfied. We've completed our training. So there's our loss starts at 1.5, and then goes down to a reasonably suitable value, and our accuracy goes up and up and up, and our training set has reached about 0.9 something. Okay, well, next video we'll look at how we save the model and load the model, look at the code for that, and then we'll go on to another TensorFlow.js example. Thanks very much for watching. Until next time, bye.